Hello there friends, welcome to this video. Let's begin with the solution of LTC AIIMS Chemistry Unit Test number 7. First question, the process of converting fresh precipitate to a colloid by adding electrolyte is known as peptization, of course, because electrophoresis is the deposition of colloidal particles, electroosmosis is the movement of colloidal particles under a semi-permeable membrane, and flocculation is same as coagulation. Which of the species is diamagnetic? So I have drawn this electronic configuration. As you can see, zinc 2+ is diamagnetic, others have unpaired electrons, so they are paramagnetic. All of the following 3D series elements show most stable oxidation state of except +2 except scandium, of course, because the configuration of scandium is 3D1 4s2. So of course it would prefer to lose all the 3 electrons and gain the noble gas configuration. Okay. Atomic radii of 4 3D series elements are given randomly in picometer. The atomic radius of scandium would be what? So you should know the variation of atomic size in D series. It happens something like that, right? So in the beginning of the series, size decreases because effective nuclear charge dominates, and after the middle of the series, atomic size becomes almost the same because electron-electron repulsions counterbalance effective nuclear charge, and towards the end of the series, because of increased electron-electron repulsions, size increases a little bit. So the first element has the highest atomic radius, right? So atomic radius is scandium because scandium is the first element of 3D series, so it should have the highest radius, which is of course 164. So the answer would be C. All the following are essential amino acids except glycine. Essential amino acids are the ones which cannot be synthesized in the body, and hence they need to be supplied in the diet. Okay. The starting material in Stephen reaction is this is Stephen reaction. We take nitriles in the presence of SnHCl. Amines are formed, and which on hydrolysis give you aldehyde. Okay, so the starting material is nitriles. Which of the following is most reactive towards nucleophilic addition reaction? We are talking about aldehydes and ketones, and in nucleophilic addition reaction, reactivity is directly proportional to electrophilicity and inversely proportional to steric hindrance. Okay. Now, because HCHO does not have any electron donating alkyl group, so its electrophilicity is more, and also it doesn't have bulky alkyl group, so its steric hindrance is minimum. So it is the most reactive compound. Coordination number in simple cubic unit cell is 6. Yes, I have tried to draw this structure of the lattice arrangement of simple cubic unit cell. As you can see, with reference to this particle, there are 4 particles which are touching in the vertical plane. One this, second this, third this, and fourth this, right? There would be a particle in the layer in front of it, right? Something like this. This would be on this, something like this, and one particle would be behind. Okay, so you can imagine that in a simple cubic unit cell, if the particle under question is placed at the origin, then the other particles, the nearest neighbors, the touching particles, they are placed along x minus x, y minus y, and z minus z. So the total number of particles is 6. That is the coordination number. Effective number of atoms in simple cubic unit cell is 1. Yes, you know that there are 8 lattice sites, and the contribution of each corner particle is 1 by 8, leading to the rank 1 for simple cubic unit cell. So both statements are correct. Shape of polypeptide chain could be either alpha helix or beta pleated sheet, and they are determined by the hydrogen bonding, and this is what we call secondary structure. Which of the following shows both Frankel defect and Schottky defect? Of course, it's there in NCERT book also. It's very popular, AGBR. 1 mole of manganese is burnt completely to form Mn3O4 under standard conditions. The amount of heat liberated is, so of course, the enthalpy of formation of Mn3O4 is minus 1388, right? So this would be 1388 positive, right? Because we're talking about the heat liberated. But Mn3O4 contains 3 mole of manganese and we only have 1. So the amount of heat liberated would be 1/3 of this, which would be this one. Enthalpy of formation of water is given in the gas and liquid phase. The enthalpy change when 9 gram of water vapor condenses. Okay, so this is a process, the condensation of gas to liquid, and this is enthalpy change, products minus reactants. So per mole of water, the enthalpy change is minus 40, and because we are taking 9 gram, so which is half mole, so of course the enthalpy change would be minus 20. So this is the correct answer. Standard molar enthalpy of formation at 298 Kelvin is 0 for Br2 liquid. For sulfur, the reference state is rhombic. For water, it cannot be 0, it's a compound. For ozone, it's positive because it is unstable. At 27 degrees Celsius, 1 mole of an ideal gas is compressed isothermally and reversibly. So this is the formula for calculating work done under isothermal and reversible conditions from a pressure of 2 atm. So either you can take V2 by V1 or you can apply Boyle's law because temperature is constant. So V2 by V1 becomes P1 by P2. You can substitute the values. P1 is 2 atm, P2 is 10 atm, R you take 2 calorie approximately, temperature is 300 Kelvin and number of moles is 1. So you work out this value, this will come out to be this one. Okay, and now because the process is isothermal, temperature is constant, so internal energy will be constant and hence delta E will be 0. Is that clear? Then what type of redox reaction is this? Of course, displacement reaction. Hydrogen is being displaced by zinc. Okay. When PBS is oxidized by H2O2, the product is lead sulfate. In this case, sulfide ion is oxidized to sulfate. So you can calculate the oxidation numbers. Sulfide, it is -2 and sulfate is +6. So a total of 8 electrons are lost. IUPAC name of this compound, this is the longest chain and this is the numbering that will give the smallest position to the functional group, right? So of course the name of the compound would be 4-methyl hexane 2,4-diol. Okay, so this is the correct answer. Which of the following statements are correct? Of course, both A and D are correct. Carbocations have positive charge, they need electron donating group. So plus I effect will be stabilizing a carbocation, and carbon ion has negative charge, it needs electron withdrawing group. Okay, so minus I effect will stabilize a carbon ion. Number of stereoisomers, of course, this double bond will not show geometrical isomerism because two identical groups are joined to one of the doubly bonded carbon atoms. As far as this carbon is concerned, yes, it is chiral, and the number of stereoisomers, if there is no symmetry, is 2 raised to the power n, where n is the number of stereocenters. In this case, it is just 1, so there would be 2 isomers. This is isomerization reaction, straight chain alkanes converted to branch chain alkanes, and for butane there is only one branch possible, of course, isobutane. Now you count the number of primary hydrogen atoms, they will come out to be 9. Methyl, methyl and methyl. The compound which does not decolorize Bayer's reagent. So Bayer's reagent is alkaline cheminophore. It is used to test the presence of unsaturation, which is there in propyne, cyclohexene, butanene and our very dear benzene. But the point is benzene is aromatic. It strongly resists the addition of OH group, right? Because it will lose its aromaticity. So it does not decolorize Bayer's reagent. So this is the correct answer. Calcium carbide on hydrolysis, it gives acetylene, and then acetylene, this is the acid catalyzed hydration. Okay, right? The hydration of acetylene, it gives you aldehyde. Acetylene is the only alkyne which gives aldehyde. All other alkynes give you ketones, and then you are oxidizing it with tolerance reagent. So of course it will give you the corresponding carboxylic acid, which is acetic acid. So this is the correct answer. This is acetylene. On reaction with 1 mole of sodium, it would be converted to the anion, which actually acts as a nucleophile. And when you react it with methyl iodide, then this is SN2 reaction. Okay, so you get propyne, and when you react it with H2PDBSO4, so this is Lindlar's catalyst, right? In the presence of a poison, alkynes are converted to alkenes, right? Because this will not show geometrical isomerism as such. So I would just write the product CH2 double bond CH and then CH3. Now, of course, if you react this molecule with HBr, Markovnikov addition will occur and we will get this molecule. Okay, so this is of course isopropyl bromide. 1,2-benzpyrene is a carcinogenic compound. It contains, this is a compound, it has of course 5 rings, and you can count the number of pi bonds, there would be 10. Consider the reaction. Okay, so the product is this benzene hexachloride, or we can also call it hexachlorocyclohexane. Total number of bonds, you can see in benzene the 3 pi bonds are being replaced by 6 Cl bonds, right? So of course number of bonds is increasing. So this is incorrect statement, hence the correct answer. Y is the electrophile in chlorination of benzene, and X is the electrophile in the chlorination of benzene, and Y is the electrophile in the sulfonation of benzene. So I have drawn the first step in which electrophile is generated. You can see that in case of chlorination, the electrophile is chloronium ion. Okay, and in case of sulfonation, this is the entire pathway through which the SO3, which is an electrophile, is generated. SO3 acts as an electrophile because it has vacant d orbitals, right? Also, an element of has a body-centered cubic structure with a cell edge of 288 picometer, and you know that for body-centered cubic there are two particles on corner, one body center. So the body diagonal, which is root 3a, it is equal to 4r. So you substitute the value of edge length, you will find out it will be root 3 by 4 multiplied by 288. Incorrect statement, identify the correct statements from the following. So this is correct, this is correct, this is correct. Potassium dichromate has triclinic structure, so this is incorrect, and hence this is the correct answer. In this case, the correct answer is this. Hydrogen on finely divided palladium is occlusion, that is absorption of gases on the surface of metals, right? And then hydrogen atoms on nickel at high pressure, it will be Chemi's option, so this will match with this, and C will match with 1 because hydrogen on charcoal, it will be Physisopt, okay? So this is the correct answer. Cloud is an aerosol, it is an example of water dispersed in air, right? So XX prime, of course, there are two atoms. It has to be linear. So A will match with third. And XS prime, it is bent T structure. So this is T shape. B matches with first. So this is the correct answer. XX prime, it is square pyramidal, but because of the lone pair bond pair repulsion, these four bonds which were earlier in plane, they get bent towards this substituent, right? XX prime is very popular example like IF7. It's pentagonal bipyramidal structure. So this is the correct answer. 17 group hydride having positive pK values HF, right? It's approximately 3, whereas HCl, HF, and HCl, HBr, and HI, they are very strong as their pK are. For HCl, it's -7. For HBr, it's approximately 9. For HI, it is approximately -10. HCl cannot form H2Cl2, whereas HF can form H2F2. The reason is fluorine atom is small and it can form hydrogen bonds, right? Which of the following element has the greatest tendency to convert to +3 to +2? Of course, we are talking about reduction, and we know that higher the reduction potential, greater the tendency for reduction. So you have to look up these values, right, either in your book or on internet. So you'll find out the maximum electrode potential corresponding to this M3 plus, M2 plus would be for cobalt, right? So that will be the correct answer. 40% solution of formaldehyde is used to preserve biological specimens. So this is a factual. Remember that. Calculate enthalpy of combustion. So for combustion, it is C8H18 plus 25 by 2 O2, 8 giving 8 CO2 and 9 H2. Okay, so we calculate for products minus reactants, right? I have done the calculation. You can work it out, and you will find out that it is minus 5.44 into 10 to the power 6 joules. This is the correct answer. Again, here the reaction is this. Entropy of the system would be entropies of product minus entropy of reactants. So you will work it out. This will come out to be 159. Okay. Equivalent weight of H2O as oxidizing agent. When H2O is acting as oxidizing agent, it will of course undergo reduction, right? Now, depending upon the medium, if it is acidic or alkaline, H2O is converted to H2O or hydroxide. So you will see that the change in oxidation state is from -1 to -2 per oxygen. Overall, it is 2, and equivalent weight is molecular weight divided by N factor. Molecular weight is 34, N factor is 2, so this is 17. So this is the answer. Then in Lasagna's test, extract give white precipitate with silver nitrate. The halogen present in organic compound is of course AgCl gives white precipitate, AgBr gives pale yellow precipitate, and AgI gives yellow precipitate, right? AgF is water soluble, so it doesn't happen to be there. Ozonolysis, of course, here we have to perform the retro-ozonolysis. Propanol, this is propanol, acetone, and this is methanol. So what we have to simply do, it's very easy. Just remove these oxygen atoms and connect these carbons together, right? So this is CH3, CH3, double bond, CH2. So this is of course isobutene. Ethine is acetylene. You react it with HBr, it will give you CH2 double bond CHBr, and now because of the resonance stabilization of the carbocation, it will be a geminal compound, right? So when the second equivalent of HBr reacts, so it would be CH3 CHBr, right? So 1,1 dibromoethane would be the major product. Is that clear? Now, question number 92. Carbon-carbon bond length in benzene is, carbon-carbon bond length is 154 picometer. Carbon-carbon double bond length is 133 picometer, right? Now, in benzene, there is resonance, of course, alternate single and double bonds. So, the average bond length would be somewhere between single and double. So, you can remember this value, it is 139 picometer, okay? Acetaldehyde is this and acetone is this, can be distinguished by all the following reagents except tollens, Fellings and Schiffs. These are the reactions exhibited by aldehyde. So acetone won't respond, so they can be distinguished. But iodoform test requires this group to be present and both of them have this. So of course, this cannot be used. So this is the correct answer. Carbonyl compound show some unique properties. They react with ammonia and its derivatives. Correct structure representing acetone hydrazone. So it's very simple, guys. You write acetone and hydrazine is NH2, NH2. Now you remove water if you are carrying out the nucleophilic addition elimination, right? So of course CH3 twice, C double bond and NH2. This is the correct answer. Okay. Then CH3CHO dilute NaOH. Everyone knows this. This is aldol reaction, and because heat symbol is there, it has to be aldol condensation. So in the first step, the base abstracts alpha hydrogen atom, which gives us the enolate ion, the nucleophile. It attacks another molecule of acetaldehyde. Then we have the nucleophilic addition product, which abstracts H plus from the solvent, and then we have the aldol addition product. Now through even CB elimination, we have OH and H leaving the molecule, and which will give us a double bond at alpha beta position, which is commonly known as crotonaldehyde. You should remember this name. So this is the major product. Glucose cannot react with sodium bisulfite because sodium bisulfite cannot open the hemiacetal cycle, right? The ring of the glucose, right? So this is the correct answer. In the following reactions, which is deuteriolysis, of course, all of them are, because instead of water, we are taking heavy water. So these reactions. 20 volume H2O2. Okay, so strength in gram per liter is 3 multiplied by volume strength. It's a very important, useful shortcut. Remember this. So actually, the gram per liter strength would be 3 multiplied by 20, approximately 60.7 and not 6.07. So this is the correct answer. Okay, right? So, and if you want to understand this, H2O2 decomposes to give you half O2. So 11.2 liter oxygen means the decomposition of 34 gram H2O2. And because 20 volume H2O2 means 20 liter oxygen has been obtained upon decomposition. So the amount of H2O2 would be 34 divided by 11.2 multiplied by 20. So you would find out this comes out to be approximately 3. Okay, very important, useful shortcut it is. Sigma bond between chlorine and oxygen and Cl4 minus is formed by which overlapping? Of course, chlorine is sp3 hybridized and oxygen has its valence electron in the p orbital. So the sigma bond would be formed by this sort of overlap. Amylose is straight chain, amylopectin is branched. 1,4 is linkage, leads to the propagation of the chain, whereas 1,6 is used for the branching, right? So this is the correct answer. And that's all for this paper. Thank you.